This is the statistics track of Module 6, and in it we're going to talk broadly about data distributions. We've already covered some of the basics of data distributions in a previous statistics track module, but we're going to talk specifically about an important distribution question, which is replacement level. Replacement level in baseball and in sabermetrics is an important concept all sabermetricians should grasp very well, and I wanted to just cover this by starting with something called the normal distribution. This is just the bell-shaped curve, and most people who study various analytics get a sense of what this really looks like. It looks like a bell, and so, a typical bell-shaped curve, when you measure something, you get a probability distribution of this. So let's say we were measuring heights of people who lived in Boston. We'd gather all these people and we'd eventually plot a histogram. This histogram could be a count of the people at different heights. So you'd measure the height and then you'd count how many people fit that height. If you did that enough, you'd reach a bell-shaped curve, what's called the normal probability distribution. So then people who are, say, this height, they're at one end of the probability distribution. In other words, they're tall, okay? They're tall people. And these are shorter people. And it's just based on where your height is, the probability of you falling in this bell-shaped curve, the normal distribution. Now, it's an important concept in all of analytics about sample size and what a normal distribution, when you get the normal distribution. But it's an important concept in baseball because remember what the normal distribution offers you, that right here in the middle you have the average, the mean, is the same as the median, as is the mode. The mean, median, and mode are all the same at the middle of the normal distribution. And sometimes distributions aren't normal though, and we care about what they look like and why they look that way. And this matters in baseball very specifically. Now, the next sort of idea here is the talent normal distribution. In other words, not just height, but what if we graphed the normal distribution of baseball talent? We'll call it just general baseball talent. But if we sampled enough people and measured general baseball talent, if we could do such a thing, we would eventually get the bell curve of the normal distribution. There would be an average level of baseball talent. So this would be the mean, median, and mode of baseball talent. But this includes lots of folks. And this is an important idea that Keith Woolner explores that we want to get to. So that would be a talent normal distribution as opposed to a height normal distribution. Now, one thing I do want to talk about here, which is very important. When you think about baseball, you think about a lot of things, but specifically baseball. There's a discontinuity between a player's talent. And the talent encompasses what a scout might call the 5 tools. What are the skills and talents of a player? They're hitting for power. They're squaring up the ball for good contact. Their ability to field the ball, their ability to throw the baseball around the diamond or even pitch the baseball if they're a pitcher. Their ability to run the bases, their running speed, and their instincts as a fielder running to make plays in the field. All that stuff I just reeled off there encompasses baseball talent. Now, what we're good at is measuring outcomes. We're not so good at measuring talent specifically. When we take metrics in baseball, we measure something. When Chadwick started measuring something, he was measuring outcomes. You remember one of the things Chadwick measured was runs per game by a player. How many runs a player scored? Those runs per game is an outcome. Now, it's certainly related to a player's talent, but there is a separation between the actual outcome being measured and the innate talent or skill of the player. So distinguishing talent and outcomes and being clear when you need to is an important concept in sabermetrics. Just to note here, a side note about what talent is defined as, the skills of a player, what they own as their innate skills because of training and genetics, and the outcomes, what we can measure what happened during a game or a set of games. So that's just a side tangent on those concepts. But let's move on to discussions now about replacement level. And we saw previously why replacement level is important. One of the key statistics thrown around today is WAR. Now, WAR stands for wins above replacement. So this key word here in WAR is what we're going to try to discuss further in this segment. So Bill James was really the first we can find to write about replacement versus average, replacement level versus average. Remember, it's about distributions and about bell curves and normal, what's normal and what's average. But what he does in his abstracts in the 80s is he argues against this concept of average ball player in 1984, but he really expands upon this in the 1985 abstract. Here's a quote from the 85 abstract. The line against which a player's value should be measured is the replacement level. This is in direct contrast to what Pete Palmer and John Thorne were talking about in The Hidden Game of Baseball. In The Hidden Game of Baseball, Pete Palmer develops this wonderful system of measuring player values, but he does it against average. He says that the average ball player is worth 0, and that's the starting point that you go from to start accumulating value. And that's an important idea that really is distinguished from this idea of replacement level. Again, Pete Palmer argued for average being 0 when he did his work. He actually talked about runs above average. Runs above average. So he would have a normal distribution. There'd be the average here, the mean, and values that he would put on runs this way would be runs above average. And you can do this for different things: fielding, base running, pitching, batting skills. But it would be runs above average, and runs below average would be negative on this side. Now, that's Palmer's idea, and James argues against it in his abstracts by talking about replacement level. So Bill James really brings up replacement level into the sabermetric thinking. As far as we can tell, we haven't seen it really discussed much or written about more in previous work. So this is what one quote: the line against which a player's value should be measured is the replacement level. Another quote, I've sort of modified it here a little. The other quote is: the replacement level is real for a baseball player. Drop under it and they release you. This is another key concept about what the definition of replacement level is. If you go under replacement level, you won't be playing much longer. And that's a real thing for baseball players. And this is another important quote from that abstract. Baseball talent is not normally distributed, but skewed. This is one of Bill James' key arguments. Instead of the normal distribution, the bell curve. Remember the bell curve? Just, you measure a lot, you get this nice probability distribution. The mean, the median, the mode all line up. But data can be skewed, and we showed you examples of this previously. If we do a histogram, it might look like that, or it might look like this. And what James is arguing is that baseball talent, the talent, is not normally distributed. It doesn't look like this. This is not what baseball talent looks like. This is what baseball talent looks like. And he's specifically talking about professional baseball players, because that's what James was studying. And he studied up and down the levels. He did a lot of work on minor leagues and major leagues, but he's really arguing against this concept of average as the baseline for measuring player value.